Okay, this is Algebra 1, Section 6.3. And we're going to be starting exponential functions. So, you guys know that if we say something grows exponentially, that means usually that it starts off slow and gets big really fast. And you can see by this little sketch that that is not a linear function. It's not a steady rate of increase. So an exponential function is a nonlinear function of the form y equals a times b to the x power. This would be what we refer to as the parent function. We'll talk about that more in a little bit. So one thing they're going to have you do in this section is identifying what kind of function it is based on a table. So let's say we have these two tables, and there's two things I want you to pay attention to. So notice that the x in this table is going up by 1. It's going up by the same amount every time. Plus 1, plus 1, plus 1. And obviously this is the same thing because they're the same numbers. So if this is going up by 1, I want to look and notice what y is doing. So this one's going up by 2. 2 plus 2 is 4. 4 plus 2 is 6. 6 plus 2 is 8. Notice that these are all the same. And I'm adding, right? So that means that this is a linear function. As x goes up by 1, y increases by 2 each time. So we're adding the same amount. I'll put that here. Adding the same amount. Okay, so now let's look at this second table. The x's are going up by 1s, but I can't add. Oh, so 4 plus 4 is 8, but 8 plus 4 is not 16. But what I do notice, to go from 4 to 8, I could multiply by 2. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. If you're multiplying the same thing from one y to the next, then we know that this is an exponential function. So as x increases by 1 each time, the y's are multiplied by 2. So if you're adding the same amount, it's linear for the y's. If you're multiplying the same amount, it's going to be exponential. So this is what graphs of exponential functions look like. And remember, that's the parent function. So if this is greater than 1, your graph is going to look like that. Or like this. The pencil one means that this number is greater than 0. The number that I'm multiplying this by is greater than 0. If this number is negative, in other words, it's less than 0, it's going to be a reflection of this graph over the x-axis. So it's going to be going down like that. And then these are the graphs when this number is negative. So again, if the number that we're multiplying that by is greater than 0, it looks like this. And if it's less than 0, negative, it looks like that. So let's look at one of the examples, one of the problems from your worksheet, and it's number 6. So we want to graph f of x equals 1/2 times 6 to the x. So first of all, I know, let's go back to this, and it's y equals 1/2 times 6 to the x. All right, so this is b, and it's greater than 1, so I know it's going to be one of these graphs. And let's look at a. A is 1/2, and that is definitely greater than 0. So my graph is going to look like this. And the value when x is 0 is going to be whatever this is, a. So I know, let's see, this is 0, 1/2 is about right there. The red marks the parent function. Well, the parent function would be y equals 6 to the x, which is in red. And if I change, notice here on the parent function, a is 1. If I change a to 1/2, it becomes the penciled graph. We'll be doing some of these on the graphing calculator too, so that you guys can see the transformation, the difference between this, which would be the parent function, and this one, where a changes. So, but it's easy to do this by hand too. Just write down the formula, and remember we can set up a table of values. Just pick two values, 0 and 1. When x is 0, remember 6 to the 0 power would be 1. 1 times 1/2 is 1/2. Let's see what happens when x is 1. 6 to the first power is 6. Half of 6 is 3. And then it's going to ask you to describe the domain and range of this function. And remember that the domain is everything x can be. And the range refers to the outputs. In other words, what can y be? Here's how you're going to remember this. X comes before y in the alphabet. Domain comes before range in the alphabet. So if you look at this graph, there's nothing that x cannot be. X can be anything. So that's why we say the domain of f is all real numbers. But the range is a little different, because notice that there is nothing down here where y is negative. So that means that the range of f is all y that's greater than 0. This means only positive outputs. Like I said, we'll be doing a lot of these graphs in class using the graphing calculator, because I really want you guys to be comfortable with using that technology. And that is it for 6.3.